So tonicity is going to describe what the relationship or concentrations of solute to solvent, okay? What is solute? Give me an example of a solute. Yes? No? I thought that was a hand. Okay, what is solvent? Let's start with that. Water. What does water do for most substances? Dissolves. So what's solute going to be?
The thing that dissolves because of the water.
The thing that is being dissolved. So give me examples of solutes.
Salt.
Salts. What else? Sugar. Good. Salt, sugar. Those are good examples, etc. Anything in this class besides water is going to be my solute. Okay? Water is always going to be the solvent. Unless if I tell you something different. Now, we're going to look at this diagram right here, hypotonic. If I gave you this diagram on the test, and I told you that the green dots were solute, what can you tell me about the concentration of solute to solvent? And this green area is the outside of the cell, and this orange area is inside the cell. Give me something about the solute. We're not showing any movement. You're just looking at green dots.
Wait, no, I had it in my head. I totally forgot what I was saying. It's high inside the cell.
Okay, the concentration of solute is actually less outside than it is inside. That is perfect. So if the concentration of solute is less outside than inside, where is there more water? Look at it. Everything else is water.
The outside is more water.
The outside is more water because you already wrote in your notes, wherever there's more solute, there's less water. Okay? So in which direction does water always move? What? High to low. So where is there more water? So in which direction is water moving? Which is what? Inside. From high to low. That white arrow would represent water. Water moves in. Okay? I'm actually going to change the color to blue so it looks more watery. There. Okay? So that's water. Now, what's going to happen to the cell if water starts moving into it?
Less solute.
Water is moving into the cell. What's going to happen to the cell? Expand. It's going to swell up, and eventually, if water continues to move in, it'll burst. I asked you to look at this picture and tell me the solute to solvent concentration, or tell me anything about the solute. The concentration of solute to solvents is equal. Or you could say the concentration of solute outside is equal to the concentration of solute inside, if you want to write it that way. In which direction is the water going to move? What do molecules always do? Move. So they're going to move back and forth, okay? They always move. So you want to think they're not going to move, but they're just going to keep going back and forth because they're balanced. Tell me about the solutes in a hypertonic solution. The concentration of solute is greater on the outside. Think of this word hyper. Where do hyper people like to be most of the time? Outside, okay? So think of that. Try to remember that. More solute outside because hyper people like to be outside. So where's there more water?
Inside.
Where?
Outside.
In the inside. Because the concentration of solute is greater outside, so water is going to move out. Good. Remember that the blue arrow is water. What's going to happen to my cell?
It's going to
shrivel up, shrink. Anybody ever have a throat infection?
Yes.
What do you do when you have a throat infection? First, you drink water, yes. Always hydrate. What do you do to help the throat infection immediately?
Drink
lemon. What else? That's pH. What else?
Tea. Honey, lemon, and tea.
What do you gargle?
Salt.
Salt. What is salt in this class? A solute. You put salt all over the outside of a bacteria cell, and what's going to happen to the water in the bacteria cell? It will go out of the cell, and hopefully the bacteria will go. I know, I always get that every year. Right, this picture shows outside of the cell here, inside of the cell. So first question is, what type of solution is this? Who could tell me? Yes. How do you know that?
Because there's less of the solute on the outside.
Good. There's less solute outside. Here's my next question. If I draw this right here, okay, what did I just draw? I'm actually going to rephrase that question. What type of transport did I just draw? Raise your hand if you could tell me that. Active. How do you know it's active? So the molecule went from less to more. Now, the molecule went through active transport and it went into the cell. What type of active transport is that? Who could tell me that? Endocytosis. Awesome. Another picture. If I draw this, okay, watch. Ready? What did I just draw? Think. Look what I'm pointing to. Am I pointing to a solute?
No. Is it water moving?
Awesome. What's that called when water moves from high to low? Osmosis. I didn't point to a solute. Everything else is water. We know the concentration of water is greater outside. It moved from high to low. All right. What did I draw now? I took a solute and I went here and here. Wait, before you answer, who can tell me what type of transport is this? What type of transport?
Passive.
Passive. How do you know that?
Because it's going through the proteins.
It's passive because
It's going high to low.
because it's going from high to low. If I ask you the why on the test, the only answer is that. What type of passive transport did I just draw?
Assisted
Facilitated.
or
Facilitated what? How do we know it's facilitated diffusion? Because the solute is going through a protein from high to low. And I know I spelled diffusion wrong.
I was right.
Diffusion. Regular diffusion would be this. A molecule traveling from high to low through the lipid. Okay? And through the protein is facilitated.